Good morning. This is the first session of thermodynamic relationship. So this relation is very important as per conventional point of view, and some different types of objective questions have been asked from this section. Okay. So first of all, we will start this first equation. This f is function of x, y, z. So look at this equation. F is function of x, y, z. So if f is function of x, y, z, in that condition, this del x by del y at constant function into del y by del z at constant function into del z by del x at constant function is equal to 1. This is very simple equation. You can understand, you can remember this equation by proper logic. So this is the one equation. So if f is function of x, y, z, then del x by del y at constant function is equal into del y by del z at constant function into del z by del x at constant function is equal to 1. The product of all three terms will be equal to 1. Okay. Next equation, if temperature is function of pressure and volume. As you know that PV is equal to mRT. For fixed M and R, this temperature is function of pressure and volume. In that condition, the del P by del V at constant temperature into del V by del T at constant pressure, into del T by del P at constant volume is equal to -1. Product of all three terms will be equal to -1. So this is also simple equation. You can understand with proper logic. There should not be any problem. So this is the second equation you need to remember. Now let us come on the third equation. Third equation, actually this is very important. There are four equations of Maxwell equation. So we will be deriving different equations one by one. So before deriving the set of Maxwell equation, we have to go through some basic fundamental. Okay. So first equation, this basic fundamentals equation, we have to follow this one. So you need to understand this one. This basic equation, this format is that if dz is equal to m dx plus n dy, then for z to be exact, this del m by del y at constant x is equal to del n by del x at constant y. This equation is easy to remember. How? Yes, have a look at the equation. If dz is m dx plus n dy, for z to be exact, this del m by del y at constant x, is equal to del n by del x at constant y. So for z to be exact, this is the equation is this, both terms should be equal. Okay. Now come on the first equation of TDS. Okay, Maxwell equation. We know this TDS equation. This is the TDS equation. TDS is equal to du plus PdV. Therefore du is equal to TDS minus PdV. Okay, this equation can be compared with this equation. Okay, so just I'm writing this equation just below of this one. This dz is equal to m dx plus n dy. If you compare both equations, you can find that m is equal to t, x is equal to s, n is equal to minus p, and y is equal to v. So if you're putting this value in this equation, you will get, for u to be exact, just similarly, if for this equation, if z to be exact, you have to just both terms are equal. Similarly, if du is equal to tds minus pdv, then for u to be exact, just put this value. This m is in place of m, just put t. In place of x, you put s. In place of n, put minus p. In place of y, put v. So in this equation, this dm by dy, that means dt by dv at constant s is equal to minus del p by del s at constant v. So this is the one equation of Maxwell. So this is very easy to remember. Okay, so you need to know this basic equation, and you are supposed to know this equation. If you are comparing this equation, you will get first this equation, this TBS, dt by dv at constant s is equal to minus del p by del s at constant volume. TBS, this, just have a look at this denominator. This, even volume is varying, s is constant. In this condition, just opposite, this on the right hand side, s is varying, volume constant. So this is a sequence between these both equations, both terms. So if volume is varying, s is constant, but opposite side, other hand side, this, if s is varying, then v is constant. So this is the one equation of Maxwell. So this is all about the first session of thermodynamic relationship. Thank you.